Good morning, everyone. We're going to start with normal distribution today, which is very important. Okay, normal distribution, we have talked about it in the past. It's bell-shaped curve, okay, also known as normal distribution and also known as Gaussian distribution. These are a couple of examples of bell-shaped curves, okay? And this is the formula that describes this distribution. You do not have to memorize this formula, as I told you before. So anyway, but just to give you an idea, a quick review, pi is the universal constant that you know, okay? Then mu is the population mean and sigma is the population standard deviation. So it's not really as complex as it looks. So density function is defined by f of x is equal to 1 divided by standard deviation sigma times square root of 2 times pi, okay? Times e to the power some value, and that is negative x minus mu whole square divided by 2 sigma square. And that's what it is. Now, there are some properties of normal distribution that we're going to talk about. So let's go ahead and talk about them. Of course, we are dealing with continuous random variable. Remember, we defined continuous random variable. Continuous random variable. Okay, so here are some properties of normal distribution. The values of x, that's the continuous random variable, comes from the real number line. That means it could be anything from negative infinity all the way up to positive infinity. So x is an element of, so this e looking is epsilon kind of Greek letter. X is an element of negative infinity to positive infinity. That is the entire number line. That is what you're more used to. 0, 1, 2, 3, negative 1, negative 2, negative 3, and that's what it is. Now, the distribution is bell-shaped or symmetric. So that's one thing you may want to pay attention. So let's look at the red bell-shaped curve. Okay. If you look at the red bell-shaped curve, as you can see, left half is the mirror image of the right half, or right half is the mirror image of the left half. That's what symmetry means. Okay, it's symmetric. So right in the middle, vertically, if you were to put a mirror facing one side, okay, if you put a mirror facing this side, then inside the mirror you will see what is on the right side. On the other hand, if you put a mirror facing this side, inside the mirror what you will see is this side. So they are mirror images of each other. Mu is the population parameter, right? Mu is the mean, the population parameter. That is the center of the data points. Remember, we talked about center or middle or the highest concentration or focus of the data points. Okay, mu is the center of the data point. So for this red one, mu is going to be just 1. At 1, they have the highest concentration of data. The population parameters mu and sigma square is the variance, a positive number that defines the spread of the data points. Sigma square, as you know, sigma square is variance. Sigma square is variance, whereas sigma is standard deviation. Okay, square root of variance is the standard deviation. As you remember, probably from our earlier discussion on standard deviation, what does it tell you? It tells you how close the data set data points are in a data set with respect to the average or the center or the middle, okay? How compact or how close the data points are. The higher the standard deviation is, the more spread out the data points are. The higher the standard deviation is, the more spread out the data points are. And remember, sigma is the population standard deviation and S is the sample standard deviation. Similarly, sigma square is the population variance, S square is the sample variance. The next thing, the parameters, remember parameter versus statistic. Statistic is the characteristic of a sample and parameter is the characteristic of a population. Like X bar is the sample mean, mu is the population mean, sigma, sorry, not sigma, S is the sample standard deviation, sigma is the population standard deviation, S squared is the sample variance, and sigma square is the population variance. So the Greek letters go with the population and regular lowercase English letters go with the sample. And remember this distinction. Now, if you have mu, population mean, and variance sigma square, okay? If you have mu, population mean, and variance sigma square, it uniquely identifies the normal or Gaussian distribution, okay? If you have mu and sigma square, it will uniquely identify. That means there is only one such normal distribution with population mean mu and population variance sigma square. And normally we denote it by this symbol. X is a random variable that is normally distributed with mean mu and variance sigma square. X is a random variable that is normally distributed with mean mu and variance sigma square. That's what it is. So just to summarize the properties, X comes from the number line. The distribution is symmetric. That means left half is a mirror image of the right half. Okay, mu is the population mean, sigma square is the population variance. And if you know mu and sigma square, that uniquely identifies the normal distribution. And there is only one such normal distribution, by the way, if you have particular value of mu and particular value of sigma square. And the normal distribution we denote it by this symbol, okay? X is normal, this tilde sign is telling you the variable, random variable X is normally distributed with the mean of mu and variance of sigma squared. That's what it is. Is it okay, everybody, so far?
Yeah.
All right. So let's go ahead and continue. You probably remember, but I would still like to remind you, sigma is the standard deviation. Sigma is the standard deviation that is always greater than or equal to 0. That means it's a non-negative number. That means it's 0 or positive. So standard deviation cannot be negative. The way we define standard deviation, the smallest value it could have is 0. Okay? Other than that, it's going to be a positive number. Now, this is the empirical rule that we talked about previously for the bell shape. If you moved one standard deviation to the right and one standard deviation to the left from the mean, okay, you'd include approximately 68.2% of the data. If you moved 2 standard deviations to the right from the mean and 2 standard deviations to the left from the mean, you'd include roughly about 95% of the total data. If you move from the mean 3 standard deviations to the right and 3 standard deviations to the left, you'll include roughly about 99.7% of the total data. That's what you do. Okay. One special normal distribution that I'm going to talk about that has a mean mu of 0 and standard deviation of 1. This is a special normal distribution that has a mean mu 0 and standard deviation sigma is 1. That is called standard normal distribution. Oops. Is called standard normal distribution. All right. If you have a normal distribution that has a mean of 0 and standard deviation of 1, it is called standard normal distribution. Okay, any question, anybody so far? Everybody okay? No questions?
No questions.
No questions so far? Okay, all right, Alicia. Then the next topic, so this is a lot of definitions, a lot of getting to know the properties of normal distribution. There is one thing that we are going to talk about is called cumulative density function. Cumulative density function. What is a cumulative density function? See, let's say you are right here, okay? So all the probabilities, okay, leading up to the point of consideration. So this is the point I am considering. So everything, so cumulative means you accumulate all the probabilities. So all the area to the left is gonna represent the cumulative probability. So if I say, let's say probability of X is less than 2 or less than equal to 2, right here is going to be everything from this point all the way up to negative infinity. This curve in essence actually goes to negative infinity in theory, and to the right it goes to positive infinity in theory. However, it falls off so quickly after 3 standard deviations that there is barely any data, or pretty much you can assume that there is no data there. Okay, it just ends somewhere around here. Okay, for practical purposes, it ends here. Cumulative probability distribution is when you accumulate the probabilities. So let me just draw a diagram. Let's say this is a bell-shaped curve. So let's make it a simple standard normal distribution with a mean of 0 and standard deviation of 1. This is a simple standard normal distribution with a mean of 0 and standard deviation of 1. Okay. Now look, if you, let's say you're here, 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 1 standard deviation, -1, -2, -3, -4. If you want to find out the cumulative probability, okay, probability that X is less than or equal to -4, you're going to be considering only this area. If you want to find out probability of X is less than or equal to -3, -3 is right here, you're going to be considering this plus this area. Okay, everything together, all the way up to this. If you're going to be considering probability of X is less than or equal to -2, then you have to consider, so this is -2, everything to the left of this. So this area, and everything to the left. If you are to consider probability of x is less than or equal to -1, and -1 is right here, you're going to consider everything to the left of that. Okay? If you want to consider probability of x is less than or equal to 0, is going to be everything to the left. This one is easy to find out. What is to the left? Can anybody tell me? What is the probability of x is less than or equal to 0? Anybody wants to try it? Remember, this is symmetric, meaning left half is a mirror image of the right half.
Would it be 0?
Not quite.
Or whatever those numbers equal out to?
You can actually give a number to this. You know what the answer is. You just think about it a bit.
4.
Probability cannot be 4. Probability has to be between 0 and 1, or between 0% and 100%. Anybody wants to? Where is Jerry? Is Jerry here? I see Jerry.
Yeah, I'm here.
What do you think?
Could you repeat the question, please?
What is the probability of x less than or equal to 0?
It's anything before accumulated before the 0. So from the -4, so on, then the 1, anything behind 0 on the bell curve.
Yes, it actually doesn't end in -4. It goes to -5, -6, all the way up to -infinity.
You said it was so small that like it,
Yeah.
Yeah.
Yeah. But what is that answer? Anybody? Nobody knows? What is the probability of x is less than or equal to 0?
-infinity.
Remember, probability has to be between 0 and 1, or between 0% and 100%. Between 0% and 100%. So one last chance. Nobody? One press. You wanna try it? One press. Okay. All right. So I just told you that bell-shaped curve is what? Symmetric, isn't it? Bell-shaped curve or normal distribution, it is symmetric. So what does it tell you? If it is symmetric, left half is a mirror image of the right half, correct? Left half is a mirror image of right half. So you have to remember all the area under the curve must have to be 100%. That's a fact I didn't tell you. That's why probably you are struggling to answer this question. All the area under the curve is 100%. All right. Now, left half should be half of 100%, and the right half should be half of 100%. So left half is 50%. That is to say, probability of x less than or equal to 0 is 50%, or 0.5. Now, probability of x is greater than or equal to 0 is also which one? Everything to the right. That's also 50%, or 0.5. Now, does this make sense to you guys? Because remember, I told you bell-shaped curve or normal distribution is symmetric about the middle or the center of the data point. Left half is a mirror image of the right half. So if the total is 100%, the left half must be 50%, and the right half must be 50%. That's what it is. All right. Okay, so let's clear it up. So cumulative probability distribution is basically you accumulate. Now, if you graph the cumulative probability distribution, this is how it kind of looks like. Interesting. It's kind of like an elongated S, and probability has to add up to 100%, or this is going to be 1. Okay. So this kind of actually goes a bit more like that. Okay, that's what it is. It's an elongated S. So this is cumulative density function. Cumulative density function. Okay, it's an elongated S. Cumulative density function. So if you add up the probabilities as you go from left to right, okay, as you go from left to right, and if you plot it, this is how it's going to look like, or this is how it's going to look like. Now, the next topic is this. If you have two normal distributions, or let's say one normal distribution rather, if you have one normal distribution, okay, with a mean of mu and standard deviation of sigma, okay, you can go from this arbitrary normal distribution to a standard normal distribution that has a mean of 0 and standard deviation of 1. If you have any arbitrary or any normal distribution, you can take that normal distribution and translate, or map rather, you can map it to standard normal distribution. Standard normal distribution is when you have a mean of 0 and standard deviation of 1. Standard normal distribution is when you have a mean of 0 and standard deviation of 1. Okay. Now, how do you go between the two? There is a way to go between the two, and that is this formula. For population, Z is equal to X minus mu over sigma, and for sample, Z is equal to X minus X bar over the sample standard deviation. So this is for the population. If you want to go between population, this is for the kind of sample. Now, this is a very important formula. You'll be using it a lot, and I kind of want you to memorize it. So Z is equal to X minus X bar divided by S. We will be dealing mostly with samples, so we are going to be using this formula. Z is equal to X minus X bar divided by S. It's also called Z-scores formula. It is also known as Z-scores formula. Now, whenever you see, from now on, whenever you see the term Z in this class, you should be thinking of standard normal distribution. Okay? Remember, standard normal distribution has a mean of 0 and sigma of 1. Standard normal distribution has a mean of 0 and sigma of 1. I will be asking this question many times. Again, please listen to this. I will ask you what is a standard normal distribution many times in the class. you should be saying that it is a normal distribution with mean of 0 and standard deviation of 1. This is extremely useful because normal distribution probabilities, if you want to find the probabilities associated with normal distribution, you technically have to use this formula. Okay? And you cannot manually do it. You cannot manually do it. You could, by the way, but it will take you a lot of time. So what you need to do is this. You need to use a table called standard normal distribution table or z-scores table. And that's a table I just sent you. So I sent you a class note, lecture number 4, okay, class notes 4. In that class notes, by the way, you will find the very first thing is a formula sheet and a bunch of formula sheets and tables. And those are things that you will be needing for the rest of the semester. So let's go ahead and look at it. So this is a table. I need to give credit to the author Triola. I'm using his table. This is a good table. All right. And I used this book before, so I still have the table. So it's a pretty standard table. You can find it on the internet. You can go and search for a z-scores table. You'll get quite a few of them. Okay. So this is the z-scores table. So look at this. So I'm going to kind of describe this thing to you. This gives you these numbers gives you in the middle, gives you the cumulative probabilities. So cumulative probabilities, cumulative probabilities. It gives you cumulative probabilities. What it is, so if you're finding this value, probability of x is less than some value, let's say this is -1, okay, less than -1, then you are talking about the shaded region, okay? And if you want to find that value, you look at the z-score, okay? In this case, actually z, not x. So z, whenever we use z, we are implicitly assuming that mean is 0 and standard deviation of 1. Z is less than 1. You look at this column, this first column that says z, and then look for -1. Where is -1? Right here, -1. Okay. Now, -1 is the same as -1.00, right? Probability of z less than -1 is the same as probability of z less than -1.00. So 00 column is this column, and this is the value. So probability of z less than -1 is .1587. So if this is your -1 point, the shaded region is going to be 0.1587. And we are going to be using this table extensively throughout the semester. Okay. From now on, pretty much all the things that you're going to be doing, we are going to need to use this table. So please make sure that you know how to use this table. So let's go ahead and find a bunch of other values. What if I want to find probability of z is less than or less than equal to, it doesn't matter, because the probability of a single point in continuous case is 0, remember? So it doesn't matter whether you write z is less than or less than equal to. So let's say z is less than equal to -1.5, okay? So let's make it even a bit, okay, let's keep it simple for now. So 1.5, z is less than equal to 1.5. So we go to the z column and look for negative 1.5. Do we see a negative 1.5? Right there. And we look at the 0, 0 column. Okay, that gives me 0.0668. 0.0668. Now let's find another value. Probability of Z is less than or less than equal to negative 1.37. I just made it up. Again, we are going to look at the Z column, right? Negative 1.3. So negative 1.3 is right here. Now this time it is 7, negative 1.37. So you have to go along this row up to the point where you come to the 0.7 column. Do you see? 0.07. So it's gonna be this value, 0.0853. You should be very comfortable finding the Z scores or cumulative probabilities associated with Z, okay, for different Z values. Now there are two tables. One is for negative Z scores, okay, negative Z values. Another is for positive Z values. And if you look at this table, negative Z values, so if this is 0, it's gonna be to the left, right? Positive Z values is gonna be to the right. The next page here is gonna give you the positive Z scores value. I'm gonna ask you a simple question here. So let's keep it Z less 0.0668. So clean it up. Probability of Z is less than negative 1.5 is 0.0668. So let's say this is my negative 1.5, okay? Now, here is another question I'd be asking everybody. I want you to participate and I want you to try. So what is the probability of Z greater than negative 1.5? So Z less than negative 1.5 is this area, okay? What is the probability of Z greater than negative 1.5, which means I'm looking for this area. So I want you to try it and tell me. Everybody, please try it. Anybody? Any response? No one has any response?
Anything above 0.0655?
Remember, 0.0655 is this area, okay? So this area is 0.0668, 0.0668. There's this area, this shaded region. So that's given by this. So probability that Z value is gonna be less than negative 1.5 is gonna be 0.0668. I'm asking for greater than. The probability that Z value will be greater than, remember, Z values are horizontal, okay? Horizontal values are z values on the horizontal line. Probability that z is going to be greater than negative 1.5. That means I'm asking for the blue shaded region. What is the area of the blue shaded region?
Would it be 0.933?
0.933, I think so. Yeah, is 0.9332. Who is talking?
AJ?
AJ, okay, thank you, AJ. It is 0.9332. Why? Remember, just a few minutes ago, I told you the area under the entire curve has to be 100% or 1, right? Area under the entire density function has to be 1. If that is the case, then we know that this red shaded region is 0.0668. Then the blue shaded region must be 1 minus 0.0668, which is the same as 0.9332. That's what it is. And that's how you should be thinking. Another way of writing the same thing is saying this. This thing is equal to 1 minus the probability of z is less than negative 1.5, okay, which is what I wrote down here. The blue shaded region must be 1 minus this red shaded region. That's exactly what it is saying. 1 minus the probability that z is less than negative 1.5. That's the red shaded region. That's what it is. This is something you need to feel very comfortable about, by the way. I mean, really comfortable doing this thing. You should be very comfortably going back and forth. Now, let's clean it up. Let's find another example. So I'm going to spend a bit of time here. Probability of z is less than negative 0.33. Okay, z is less than negative 0.33. So let's go down here, negative 0.33. So look, 0.3 is right here, right? So if we go along this row, this is 0, 0, 0, 1, 0, 2, 0, 3. So this is your value. So it's going to be equal to 0.3707. Or if I were to ask you, find the probability of z is less than negative 0.59. So you go to negative 0.5, which is right here, and you go along this row all the way to the last item, which is what? 0.2776. Remember, on the top, the numbers go from 00, 01, 02, 03, 04, 05, 06, 07, 08, and 09. Remember that. Okay. Now let's do the positive z-scores. It's the exact same thing. Only difference is that positive z-scores is going to be to the right. So let's find probability of z is less than 0.47. What is the probability that z is going to be less than 0.47? Now remember, or pay attention that positive values of z is to the right of 0. So that means all the values must be greater than or equal to 0.5, because this, to the left of this vertical line, the area is 0.5 or 50%, right? So for positive z values, all the probabilities must be greater than or equal to 0.5 for positive z values. So technically for 0 is 50, right? Or 0.5, 50%. So for 0.47, so we're going to go and look at 0.4, which is here, the z column, okay? And then we go along the row up to 7, which is right here, 0.6808, 0.6808. You should be able to use this table very easily and find the values. Now, what if I asked you the same thing, probability of z greater than 0.47? So now instead of looking at the area to the left, we are looking at the area to the right, which is again the same, is gonna be 1 minus, we know the entire area under this density function is 1. So if we take away the left side, what we will be left with is the right side. So 1 minus the left side, but the left side is this, probability of z less than 0.47, which is the same as 1 minus 0.6808. So 1 minus 0.6808 is going to be 0.3192. Is 0.3192. So probability of z greater than 0.47 is 0.3192. Let's do more examples. Okay. So let's find the probability of z greater than, not less than, greater than 1.28. Okay. So remember, greater than means we are looking for the area to the right. Okay. Greater than means, so let's say this is 0, this is 1.28. Okay. So we are looking for this area. Now, please note that this table is cumulative from the left, cumulative this table is cumulative from the left. That means it gives you area to the left, not to the right. Area to the left. So now look, if we look at 1.28, so where is my 1? Well, I mean 1.2, right here, 1.2. 1.28 is gonna be right here. Oops, not here, sorry. Right here, right? 0.9897. 0.9897. There's gonna be area to the left, 0.9897. But I don't want that area. I want the area to the right. And it's very easy. So you'll do subtraction, 1 minus the probability of z less than 1.28. Now, probability of z less than 1.28 is this area, which is this value. So it's going to be 1 minus 0.9897. 1 minus 0.9897 is 0.0103. 0.0103. That's
Hey,
what.
Professor, isn't it minus 0.8997, not 0.9897?
Oh, sorry, I made a mistake. Thank you.
You're welcome.
8997. Sorry. So change this number to 0.8997. So this is going to be 0.8997. So 1 minus 0.8997 is 0.1003. So instead of this, is going to be 0.1003. Thank you for paying attention. So that's what it is. Now, do you feel confident that you can do these things on your own? I know it might be a lot of information, but we are going to be doing it so much that you will get tired of it. Okay? this normal distribution. This is very, very important. Based on this, the rest of the topics, you'll get a mastery of it based on how much you learn here. And if you understand the normal distribution, how to go back and forth between any normal distribution and standard normal distribution and finding the associated probability, then you're good. You're well prepared. So let's do, I think I'm gonna stop here with this stuff. Then I'm gonna continue. The best way to do things is finding the solution to problems. So remember that z-scores formula. Z is equal to x minus x bar divided by s. Remember that formula, z-scores formula, and we are going to be using it. By the way, do you remember Chebyshev's rule by now? Chebyshev's rule. We actually used it in Chebyshev's rule, but we didn't call it Z at that time. We kind of called it K, okay? We didn't call it Z because when you use the letter Z, it kind of automatically implies you're dealing with normal distribution. But Chebyshev's rule is applicable to distribution that is not normal. So that's why they used a different symbol, K. All right, so now the average income in a city is 35,000, okay? And the standard deviation is 7,000. Assume that the income in the city is normally distributed. The average income in a city is 35,000 and standard deviation for the income is 7,000. Now, assume that it's normally distributed, so it is important. And also I should have added here another statement, exclude extreme data points, What it means is that exclude people, those who are making millions of dollars, okay? Exclude those numbers. Or people, those who are not making anything at all, maybe. Maybe people, those who are not making anything, we could include them. But particularly if you include people, those who are making multi-million dollars, then it might be a skewed set. So for the sake of argument, we exclude extreme data points. It could be extremely large or extremely small, okay? So excluding those, income is normally distributed with a mean of 35,000 and standard deviation of 7,000. So if you think of it this way, mean is 35K and income is 7K. I mean, standard deviation is 7K. This is bell shape. By the way, I kind of introduced this problem. I like it and don't like it. Income in the real world is not measured in terms of average. It's measured in terms of median, okay? They don't say average income, they say median income. The advantage of having median income is that extreme data points do not have any impact. Maybe I'll change this problem from income to number of hours students study. Then it will be probably more real world sounding. But for the sake of learning, it really doesn't matter. So just keep in mind, income is calculated in terms of median, not average. Remember, we did average, okay? We did mean or average, right? Then median, which is the middle of the data points when you ordered them. And then the last thing of measuring center was mode. We did talk about it. Depending on your situation, you use either this, or this. Mean, median, or mode. That's what it is. So let's sketch it here again. 35K and 7K. Now, what do they want you to find? Find the z-scores for somebody who makes 38,500. So easy. Z is equal to x minus mu over sigma. X is the data point that we are considering, which is 38,500. 38,500 minus mu is 35,000. All of it divided by sigma, which is 7,000. So what is it? 3,500 divided by 7,000. 35,000 going to 7,000 twice. So it's going to be 1/2, or z is equal to 0.5. Now you can be, I could ask you, find the probability that z is less than 0.5, right? Okay, which z, so 38,500, okay? So this is 38.5. So let me take the background off, 38.5. If I tell you, find the probability that z is less than 0.5, which in essence is telling you the following. You are finding the probability that x is less than 38,500. That means then people, what is the probability that people, a randomly selected person, would make less than 38,500, which would be like finding this area. By using the z-scores formula, we actually came to standard normal distribution, which is 0 and 1, and this point is 0.5. So finding, so the probability that a randomly selected person makes less than 38,500 is the same. So this area and this area is proportionately the same, okay? Probability that somebody makes less than 38,500 is the same as z falling less than 0.5. Z falling less than 0.5. All right. Now you can find these values. So this is any normal distribution with a mean of 35,000 and standard deviation of 7,000. We use the z-scores formula. Z is equal to x minus mu divided by sigma. We use this formula to get to this. That's what we did right here. That gives me a z value. 38,000 here, 38,500 translates to z is equal to 0.5. That's what the purpose or job of the z formula or z-scores formula. It translates or maps one point from this distribution to another point in the standard normal distribution. Now, if we wanted to find this probability, you could in theory do it using the formula, but we do not do that. We convert this into a standard normal distribution, okay? Convert this point of interest into this point of interest, okay? And then we look it up in the table. Now, if you look it up in the table, you'll find some value for z, and I'm gonna actually do it for you. So let's go back. We are looking for z is equal to 0.5, so positive z-scores formula, right? Positive z-scores, okay, z is 0.5, I see 0.5. See, right here, z 0.5, 0.6915. So 0.6915, so this should be 0.6915. Or equivalently 69.15%. So if you randomly selected a person from the street, okay, what are the chances that that person living in that city makes less than 38,500? That's about 69.15% chance. On the other hand, if I were to ask you the following, find the probability that a randomly selected person from the street, okay, or a randomly selected person in that city makes more than 38,500. Now that's easy, because instead of looking the area to the left, now we are looking for the area to the right. Our point of interest is still the same, which should be the same as probability of z greater than 0.5. Last time, look, it was less than, right? Now it is greater than 0.5. Now, standard normal distribution table that gives you the value for z, that gives you area to the left, remember. From this point onwards, if you draw the vertical line, the table is going to give you area to the left, okay? Area to the left, not area to the right. But we can always find the area to the right by doing the following. We know all the area under the curve is 1 minus the area to the left, which is 1 minus the probability that z is less than 0.5. 1 minus the probability that z is less than 0.5, which is 1 minus 0.6915. So 1 minus 0.6915 is 0.3085, is 0.3085. That's what it is. So if you select a person randomly from that city, the probability that this person would make more than 38,500 is going to be 0.3085 or 30.85%. That's what the probability is going to be. And you learned a lot, by the way. You did learn definitely a lot. If you understood what I have done so far, you have learned a lot. Your life will be much more easier in this class going forward, because these are the basic concepts, okay? Now we are going to apply it in the different context, but if you understood this basic, you are in a good position. Now, having said that, I'm going to ask you this question. How do you guys feel so far about the discussions that we have about normal distribution? Do you feel that you got the ideas, or do you feel that you are still shaky, you need more practice? What do you think? So far, the topics that we talked about, are you feeling that you're confident you can do similar things? Anybody? Everybody okay? No question? You're all right? AJ, is it okay?
Yeah, as you could.
Erica Robles? Erica Robles or Robles?
Yes, I'm okay.
Gloria Ortiz? Gloria Ortiz? Okay. Keone Amaya?
I'm good.
Ken William?
Yeah, I just have it.
All right. Okay, we'll continue forward. Okay, so let's go ahead and continue with this problem again. Find the z-score for someone who makes 30,500. Find the associated probability. So 30,500, that's all you need to remember. 30,500. This is our distribution of data. Okay. Now 30,500, 35,000 is right here. Where is 30,500 gonna be? Is it gonna be to the right of the 35,000 or to the left of the 35,000? What do you think? To the right or to the left? To the left, right? So this is gonna be 30,000 or 30.5K. Okay, so we need to find the z-scores, which is a mean of 0 and standard deviation of 1. The middle here is 35,000. So 35,000 is going to map to 0. Remember that. 35,000 is going to map to 0. Now 30.5 thousand, okay, or 30,500 is going to be somewhere here because this is to the left of this middle. So the z is going to be to the left, corresponding z. Now to go from here to there, we are going to be using the z formula. Z is equal to x minus mu divided by sigma. So let's go ahead and find it. Z is equal to x is the point of interest, which is 30,500. 30,500 minus mu is 35,000. All of it divided by 7,000. So it's going to be z is equal to, so 30,500 minus, so it's going to be 4,500 or 4,500. Okay, divided by negative, by the way, divided by 7,000. So these two zeros and zeros are going to cancel out, right? So 45 divided by 70 is going to be this. So 500, oops, minus 35,000, 4,500. So it is going to be 0.64. So I'm just rounding it. So 0.64. So 0.64. So income of 30,500 maps to z-score of 0.64. Now, if I were to ask you, find the probability that a randomly selected person, X, the random variable, makes less than or equal to 30,500, right? 30,500. So that would be this area you're looking for. Now, we cannot find it in this format. We are going to convert it into a standard normal distribution, which we did. That means equivalent to finding this area, which is the probability of z less than 0.64. Probability of x less than 30,500 is the same as the probability of z less than 0.64. Now we are going to find this value from
Would
where?
Sorry, would it be negative 0.64?
What is it?
Would it be negative 0.64 because you divided by a negative number?
Oh, sorry. Thank you. Negative 0.64. I forgot. Thank you. Negative 0.64. So now we are going to go ahead and find this value. We're going to look at negative z-score, positive z-score table, negative z-score table. So let's look at negative 0.64. So let's find 0.6 right here. 0.64012334. So which is going to be 0.2611. So it's going to be 0.2611 or 26.11%, or 26.11% chance that a randomly selected person would make less than 30,500. Now, what if I asked you, what is the probability that a randomly selected person makes more than or equal to 30,500? All right. More than or equal to 30,500. Now, this time, however, we are looking for this area. Now, remember our cumulative normal distribution, standard normal distribution table, right? It gives you area to the left. Always, these values I'm getting from the table, it always will give you area to the left. To find the area to the right, which is required for this one, that means if we are looking for this area, which is very easy to find, is going to be 1. So 1 is the 100%, or 1 is the total area minus the area to the left. So it's going to be 1 minus the probability of x is less than or equal to 30,500, which is saying that this area is 1 minus this area. 1 minus, now this area is actually this area. 1 minus the probability of z less than or equal to negative 0.64, which is the same as 1 minus z less than or equal to 0.64. We found it already, 0.2611. So 1 minus 0.2611 is going to give you 0.7389, 0.7389, or 73.89% chance that a randomly selected person from the population will make more than $30,500. So that's what it is. So remember, these topics, you might find it slightly harder, okay? Slightly harder at the beginning, but you will get used to. Make sure that you follow along. Make sure to do the online homework, which I will assign you. Once you do those things, you should be okay. All right. By the way, I have extended the deadline for few of the old homeworks until today, until tonight. So make sure that you work on those, because there were some requests from people about not being able to finish the homework, or they misunderstood. They thought that it was due on the midnight, whereas it was due at 6 o'clock in the morning. So I extended the deadlines for those assignments, particularly binomial distribution and permutation and combination. The deadlines have been extended until midnight tonight. So if you need to work on it, please go ahead and work on it. I think I sent you an email as well with this information. All right, next. So we did, which one? We did it for this one, 30,500. Now the next two problems are kind of slightly different. They say find the corresponding income for an individual if that person's z-score is negative 1.35 and also 0.75. I'll do both of them. Negative 1.35 and 0.75. So negative 1.35, negative 1.35, and 0.75. So we have our normal distribution here with a mean of 35,000 and standard deviation of 7,000. And we have the standard normal distribution here with a mean of 0 and standard deviation of 1. Again, standard normal distribution. Standard normal distribution, or S and D, let's call it S and D, standard normal distribution, has a mean of 0 and standard deviation sigma of 1. So this one, let's say negative 1.35 is right here. They want you to find the corresponding point right here, which is going to be X. What is the X value that will correspond to Z value of negative 1.35? And Z is equal to X minus mu over sigma. And that's what we use to go between these two, right? Now, in this case, you're given Z. Last time you were given X. So remember, last time you were given X, find Z. This time, given Z, find X. Just the order is reversed. Given Z, find X versus given X, find Z. X represents the standard normal distribution, any arbitrary normal distribution, and Z represents standard normal distribution with a mean of 0 and standard deviation of 1. So Z is equal to X minus mu over sigma. Remember, this time you are given Z, so your Z is going to be negative 1.35 is equal to X is something we are looking for. So it's going to be X minus mu. Mu is 35,000 divided by sigma, which is what? 7,000. Now you just need to solve for X. So the way you do it is multiply both sides by 7,000. Why do I do that? So that I can get rid of the denominator. So it's going to be 7,000 times negative 1.35, negative 1.35 times 7,000, which is negative 9450, is equal to this number and this number cancel out. That gives you X minus 35,000. Now to solve for X, I add 35,000 to both sides. I'm adding 35,000 to both sides. So on the right-hand side, negative and positive are going to cancel out. That's going to give me X. And on the right-hand side, if I add these numbers, it's going to give me 25,550, 25,550. So X is equal to 25,550. So this X is 25,550. So this point corresponds to this point. Let's extend this and this. This area to the left would be this area to the left, and this area to the right is going to be this area to the right. Now, if I were to ask you, find the probability that somebody makes less than, or a randomly selected person makes less than $25,550, you can easily find it. That point translates to here, probability of Z less than negative 1.35, right? Now we can go ahead and find the Z values for negative 1.35. negative 1.35, negative 1.3 right here. Negative 1.3, 0, 1, 2, 3, 4, 5. 0.0085. So it's gonna be 0.0085. So the probability that a randomly selected person makes less than 25,550 is 0.0085. Did I look it properly? No, that's why it sounded 0885. Not 0.0885. So 0.885, not 0.085. 0.885 or 8.85%. Now, on the other hand, if I were to ask you, find the probability that X is greater than 25,550, that means probability that a randomly selected person makes more than this much, 25,550, is going to be all the area to the right, which is probability of Z greater than negative 1.35. Now remember, the normal distribution table, standard normal distribution table, it doesn't give you area to the left. It gives you, it doesn't give you area to the right. It gives you area to the left. So you just have to subtract it from 1. 1 minus the probability of Z being less than negative 1.35. All right? That's what it is going to be, which is nothing but 1 minus 0.0885, which is going to be 1 minus 0.0885 is 0.9115, or 91.15% chance that a randomly selected person will make more than $25,550. Any questions so far? Anybody? No question? Okay, so let's do more practice problems here. Oh, the next one was, I already had it, so I'll just leave it here. This time I will need positive z-score, okay? There was 0.75, I remember. $35K, 7K, 0.75, let's say somewhere here. What value does it translate to? Right here, some value X is equal to something. Again, we are going to be using the Z formula. Z is equal to X minus mu over sigma, or Z is equal to X minus mu over sigma, but Z is given to be 0.75. 0.75. Remember, here you are given Z, you are looking for X. Unlike the other problems where you were given X, you're looking for Z. So X minus 35,000, mu is the 35,000, and sigma is 7,000. Now we are going to multiply both sides by 7,000 so that we have a solution to x. So 7,000 times 0.75 is 5,250. 5250 is equal to x minus 35,000. Now to solve, we are going to add 35,000 to both sides. These two cancel out, that gives you x plus 35,000 is 40,250. 40,250. So this x value corresponds to 40,250. Now, if I were to ask you the question, find the probability that a randomly selected person makes less than 40,250, which means you're looking for this area. When you're solving these problems, please always shade the region of interest. That way you will get a good feeling for the problem. Okay, you'll know what you exactly are looking for, which is going to translate to this, right? Probability of z being less than 0.75, right? Now we can look it up in the table. Z for 0.75, 0.75, what is 0.7? I can see it right here. 0.7, 5, 1, 2, 3, 4, 5 is 0.7734. Okay, so let's take it off. 0.7734. The probability that a randomly selected person makes less than 40,250 is the same as the probability that z. So this point corresponds to this point, the same probability that z is less than 0.75, right? Z is less than 0.75. And we looked it up in the table for 0.75 positive z value. That gives me 0.7734. Now, on the other hand, if I were to ask you, find the probability that a randomly selected person makes more than 40,250 is going to be probability of z being greater than, so this point again maps to this point, 0.75, which is the same as 1 minus the probability of z less than 0.75. We know already what is probability of z less than 0.75, which is 1 minus this value, 0.7734. So 1 minus 0.7734 is 0.2266. 0.2266. Or the probability is that 22.66% chance that a randomly selected person from the population will make more than $40,250. Now, I'm going to ask the next question. So we did the following. We did probability that a person makes less than 40,250. We found the probability that a person makes less than 40,000, greater than 40,250. Then what is the probability that a person makes exactly 40,250? We found it for less than 40,250. We found it for greater than 40,250. What is the probability that a randomly selected person makes exactly 40,250? What do you guys think? Anybody wants to try? Any volunteers? No volunteers? Okay. Interesting. What is the probability of a single point in the continuous case? 0. Remember, we spent quite a bit of time in the last class talking about it. Probability of a single point in the continuous random variable case is always 0. It's because, remember, the great example was the uniform distribution. Okay. It has some value over an interval and everywhere else is 0. So if you think of a single point, probability is defined by the area. If you're thinking of a single point has height but no weight, so the area must be 0. On the other hand, if I were to tell what is the probability that in the first half hour the alarm will be tested, that's this area. In the second half hour the alarm will be tested, that's that. What is the probability that exactly at 10:30 the alarm will be tested? It was 0. For a single point, the way probability is defined for the continuous case, it turns out that the single point probability is 0 always for the continuous random variable case. However, this is not true for discrete random variable case like binomial distribution we talked about, right? Binomial distribution is like x equal to 1, 2, 3, 4. You can get 1 question right, 2 questions right, 3 questions right, etc. But you cannot have 2.91 questions right. Okay? Fractional values do not make sense. So in the continuous case, due to the definition, the way we defined it as area under the density curve, area under the density function, the area has to be 0 for a single point. Always remember, for a single point, the area is always 0. That's why the probability of a single point, probability that someone exactly makes 40,250 is 0. Okay, any question before I move on? Again, the same type of problem, okay? Find the z-score for 21,000, right? Find the find the corresponding income for negative 1.5. So this is your practice problem, okay? And I think I used it again in a different context. So let's go ahead and do this example problem. So this is an interesting problem. Again, the same structure. Average income is 35,000 with a standard deviation of 7,000. However, this time I'm not going to be asking you greater than or less than, but rather I'm going to be asking you something slightly different, and you should be able to find it. So again, 35,000 average income for the population, and standard deviation is 7,000. Standard deviation 7,000. What is the variance? Can anybody tell me at least what it should be? Not the exact number. If standard deviation is 7,000, what should be the variance of the population? Remember, standard deviation is sigma. Sigma is 7,000. What is the variance? Sigma square. So it should be 7,000 square. Okay, remember that. Okay, now in this problem, we are asking something slightly different. Find the income below which, find the income below which one would be considered among the bottom 5% of the income level. One would be considered among the bottom 5% of the population. So if you are a policymaker, if you are a mayor of a city, or if you are a president of a country, you may be interested in data like this. I would like to see what is the income level for someone to fall among the bottom 5% of the society. Maybe you could implement or introduce programs and services for those people, or maybe even provide them special guidance or special help. The same question could be asked at a college or a university or at a school. We would like to find out the students who are among the bottom 5% in terms of GPA. As a college administrator, or even as a college professor, you might be thinking, I want to find out the bottom 5% of my students, and I want to provide them special help or additional help. So these are valid questions that impact your lives, okay? So if you want to find out the bottom 5% of the people in a society in terms of their income, what you do is this. So our standard deviation is 7,000, 35K. We want the bottom 5%. So that means this area to the left should be 0.05. Remember, all the area under the curve is 100% or 1. Okay, all the area is 100% and 100% or 1. So you want the bottom 5%. So we are looking for this income, how much you have to make in order to be in the bottom 5% of the income level in the society. So now we are going to go back to the standard normal distribution. Standard normal distribution that has a mean of 0 and standard deviation of 1. So now we are going to go back here, and this area should be 0.05 as well, because we are looking for the bottom 5%. And we are interested in finding this z value. And this z would actually translate to that x. This z is going to translate to that x. Now, how do I find that z? That's when your standard normal distribution table comes handy. So let's go back to our standard normal distribution, and we're going to use the table in a very different way this time. So I want you to pay attention. Okay. So we are given the area here. We know what the area should be, and we need to find the corresponding z. So far, we were given z, find area. Area is the same as probability in the continuous case. Given z, find the area. Given z, find the area. But in this case, we reverse it. We go in this direction. In this one, we go the other way. Given area / probability. Remember, probability and area in the continuous case are interchangeable. Okay. Given probability, find z. Okay. Now let's bring back our table. So far, so I'm going to clean it up for a second. So far, we were given. So far, we were given z, and we found a value in the middle, okay? Now, we need to look in the middle and find the z. So, area is less than 0.5, which is 0.05 in our case. In our case, the area is 0.05, or less than half, or 50%, right? So we have to look at the negative standard normal, negative z-scores, okay? Negative z-scores are to the left. Positive z-scores are to the right half. So now we are going to look into the table, and this is a special value, by the way, 0.05. So you see here, this is 0.0505, not exactly 0.05. This is 0.0495. That is exactly not 0.05 either. So this star value is the middle. That's 0.05 exactly. And if you follow along this, you see it is negative 1.645. Z-score is negative 1.645 for area of 0.05. For area of 0.05, z-score is negative 1.645. Now let's take this guy off, and I'm gonna go back to my stuff that I had. Right. So this is gonna be negative 1.645. So this area, to be among the bottom 5%, your z must be negative 1.645. Now you take this z value, take the z value and translate it into x, or map it into x, which we can do. Z is equal to x minus mu over sigma. Z is negative 1.645, which is equal to x is the number that we are looking for, minus mu is 35,000, all of it divided by 7,000. Now we are going to solve for x. We are going to multiply both sides by 7,000. On the right hand side, this and this is going to cancel out. That's going to give you x minus 35,000. And on the left hand side is going to be negative 1.645 times 7,000. And that is going to give me 11,000, negative 11,515. Now we are going to add these two numbers, 35,000, to both sides. If I add these numbers, on the right, positive and negative cancel out, leaves me with x. And on the right, on the left, is going to be negative 11,515 plus 35,000. That is going to give me 23,485. 23,485. So this value, this point is 23,485. Now, if you make less than $23,485 per year, you'll be among the bottom 5% of the income level in the society. You'll be among the bottom 5% of the income level in the society. All right, that's what it is. Now I could be asking the same question, what about the top 5%? Okay, sure, we could do the top 5%. Or I could be asking, what about the middle 90%? Okay, middle 90%. All of these questions could be asked. Now you can see how statistics is a subject that could be applied to many aspects of our lives. This is one example where we are applying it in the context of social or economic situations in the society. Okay, it could be statistics is one of those subjects where you will be using it, or you already are using it in your life extensively. You really are using it without realizing it. Many of the things that you do in life involve statistics. Okay, so it is important that you understand it. I think for the day I have given you plenty of information. if you are overwhelmed, please don't be. I will be going over these exact same things multiple times, not once, multiple times in the next class and the classes that are going to follow. All right, so make sure that you keep up with these materials. It's not hard, but you have to get used to it. I remember my first time learning these things. It seemed kind of not normal. It kind of seemed unusual. It takes a little bit of time to sink in, okay? And you should be patient enough to practice these problems, okay? Go over the lecture video, do the assignments, actually write it down on a piece of paper, draw the diagrams the way I did. And that's when you'll get a solid understanding of the concepts, and you'll be able to do well in this class and learn the material, and you'll be able to apply it in your life or in the real world problems. Anywhere you go, any job you do, you will be using some sort of statistics. And nowadays with data-driven economy, our economy is data-driven, everything is data-driven. And usage of data in artificial intelligence and in all businesses and technology and sciences is an amazing opportunity, amazing time to be able to know statistics and actually apply it into real world. And you can make a very good living by learning statistics, okay? And if you know programming, statistics, and a little bit of computer science, you're in big demand from employers, okay? All right, that's all for today. Thank you so very much. You folks have a wonderful weekend, even though it's Wednesday today. Wonderful rest of the week and weekend. And I will be talking to you on Monday, all right? And I will assign a homework online later today. So please start working on that. Thank you so very much. You guys have a wonderful rest of the day. Bye-bye.
Thank you.
Thank you.